Hello friends, I am Jyoti Siddhartha. This is Be Free Brainery, Be Free to Assess. I am going to present a video series on current electricity. It's the second chapter in physics. Physics 2.1. I have already presented a video series on chapter, that's 1.1 to 1.4. Do watch the videos before coming to this. This is Be Free Brainery, Be Free to Assess. This is a brief introduction about myself. I am doing my MBBS in Government Shivamogga Medical College. I am preparing this video for government school students who cannot afford sophisticated tuitions and coachings. I have presented videos on biology, physics and chemistry. These will be available free of cost because education is an invaluable, priceless and intangible asset. You can see them online or you can download it through the free laptop provided by Tamil Nadu government. This is a short introduction. You can read about me by passing the page. I would like to thank my physics sir for teaching me all the concepts and help me to understand better. Thank you sir. In this video, I will try to cover almost all the concepts and I will try to mention all the 1 marks hidden between the lines. Please remember to keep your textbook as the core material, and these video sessions will be complementary to your textbook. I will also try to teach various concepts and problem solving skills that are necessary for cracking the entrance examinations like JEE Main, AIPMT and KVPY. I hope that these videos will be very much useful for you, and I will be expecting more government school students to get government college seats. During the course of video, please pause the video to make notes, write the equation systematically so that you can understand it better. I have presented this video as how to write and present the answers in your board examination because presentation plays an important role in fetching you a very good mark. Let's begin. Have to see what is current electricity. Current electricity is a branch of physics that deals with the study of motion of electric charges. The previous chapter is concerned with the electrostatics, the static electric charges or charges at rest. Current electricity deals with the motion of electric charges. Then we have to see what is EMF. EMF means electromotive force, the external energy required to drive the free electrons in defined direction is called electromotive force in defined direction. It is the work done in moving a unit charge from one end to other end. Then what is current? Current is the flow of electrons in a conductor. Current is defined as the rate of flow of charges across any cross-sectional area of a conductor. It's the rate of flow of charges. Rate means I is equal to Q by T. Q is the charge and T is the time. The instantaneous value of current. Instantaneous means at the time. அந்த குறிப்பிட்ட நேரத்துல கரண்டோட வேல்யூ என்ன அப்படின்றத கால்குலேட் பண்றதுக்கு I is equal to dq by dt. Current is a scalar quantity. It is one of the fundamental quantity. In the 11th standard, you may come across what are all the fundamental quantities and what are all the derived quantities. The fundamental quantities are 7. They are length, mass, time, electric current, temperature, amount of substance and luminous intensity. Electric current is a fundamental quantity. It is also a scalar quantity. Scalar quantity means it has only magnitude. The direction of the current is taken as the direction of the flow of charges or opposite to the direction of the electron. So, the direction of flow of the positive charges are opposite to the direction of the electrons. Then you have to see what is drift velocity. Drift velocity. Consider a conductor XY. This is, let's say it's the conductor. Conductor is a material that conducts electricity. It allows charges to pass through. X is a conductor connected to a battery. Let E be the steady electric field. In absence of electric field, free electrons move randomly in all directions. But when the electric field is applied, electric field கொடுக்கிற போது free electrons at Y experience a force F is equal to EE, where E is the charge of the electron and E is the electric field. Small e is the charge of the electron. E is equal to 1.6 into 10 power minus 19 coulomb. 1.6 into 10 power minus 19 coulomb, where Capital E is the electric field intensity in the direction opposite to the electric field. What is drift velocity? Drift velocity is defined as the velocity with which the free electrons get drifted towards the positive terminal. The free electrons get drifted towards the positive terminal when the electric field is applied. See, A is the acceleration and T is the time between two successive collisions. Then drift velocity is equal to acceleration into tau. That's the time. So we know that F is equal to ma. So mass into acceleration. So A is equal to E by m. Since F is equal to EE. Vd is equal to EE by m into T, time. So Vd is equal to Et by m into E. So Vd is equal to mu into E, because this is mu. So mu is called mobility. Mobility is defined as the drift velocity acquired per unit electric field. This is the mu. From this we can conclude that mu is equal to Vd by E. So this is the definition for mobility. Mobility is defined as the drift velocity acquired per unit electric field. The unit for mobility is m squared v power minus 1 s power minus 1. How? See this. For velocity, mu is equal to this. So Vd is equal to v for v ms meter per second, ms power minus 1. For E, we know that v m power minus 1. So for the unit for mobility is this m power minus 1 goes upwards. So m squared v power minus 1 and s power minus 1. This is the unit for, this is the way to derive the unit for mobility. Then what is current density? Current density is defined as the quantity of charge passing per unit time through unit area. This quantity of charge per unit time. So Q by T divided by per unit area A. We know that Q by T is equal to I by A. J is the letter used to represent current density. Then what is the unit for current density? For current it is ampere. For area it is meter squared. So this will become A m power minus 2. It is a vector quantity. See, current is a scalar quantity. Current density is a vector quantity. Then what is the relation between current and the drift velocity? XY is a conductor, it has a length L, A is the cross-sectional area, N is the number of free electrons per unit volume, then Vd is the drift velocity. Then the number of electrons in the conductor is equal to NaL. How? The number of electrons per unit area is N. Then the volume of the conductor is area into length. Area into length. So this is the total number of electrons in the conductor. Charge of the electron is E. What is E? E equal to 1.6 into 10 power minus 19 coulomb. So total charge Q is equal to NaL into E, because the total number of electron is E, NaL, and the charge of the electron is E, then the total charge is NaL into E. So the time taken is equal to, time is in the second chapter in the 11th standard, you know that time is equal to distance by time. Here the distance is the distance by velocity, distance by velocity. Here the distance is the length of the conductor and velocity is the drift velocity. So time taken is this. Then the current I is equal to Q by T. So Q is equal to Q is equal to NaL into E. The time is equal to L by Vd. So the entire equation is equal to, will becomes I is equal to NaEVd. So we come to a conclusion that I is directly proportional to Pd. This is the relation between I and Vd. So J is equal to I by A. So this J and this J will get cancelled. So J is equal to NeVd. Then Ohm's law, it's a very very important law. You have also studied the Ohm's law in your 10th standard. Here, what does the Ohm's law states? Ohm's law states that at constant temperature, it's a very very important. We can say about the Ohm's law only when the temperature is constant. The steady current means constant current flowing through the conductor is directly proportional to the potential difference between the two ends of the conductor. Consider this is a conductor, then the potential, this is the one end and this is the another end. The potential difference between the two ends of the conductor will be, the current is directly proportional to the potential difference between the two ends. Then current I is equal to NAE VD. VD is equal to EE divided by M into tau. Then I is equal to NAE EE. For VD, we have to put EE divided by M into T. So by multiplying these two, we get NAE squared by M into tau into E. Then E is equal to V by L. So I is equal to NAE squared divided by ML to V. So where V is the potential difference. See, I is here the I is directly proportional to V. See, I is directly proportional to V, or V. So V is directly proportional to I. To remove the proportionality constant, we have to introduce a constant called proportionality constant V equal to IR. This is the equation you have studied in your 10th standard. V is equal to IR. This is a simple representation for Ohm's law. So I is directly proportional to V. I is, so to remove the proportionality constant, we are doing the reverse. I is directly proportional to V. So to remove the proportionality constant, we have to introduce the proportionality, we have to introduce a proportionality constant V. So V is equal to IR. What is this is the R is called resistance of the conductor. Resistance of a conductor is defined as the ratio of the potential difference across the conductor to the current. See, R is equal to V by I. It is the ratio of potential difference across the conductor to the current. The SI unit for resistance is ohm. This is the symbol. Then you have to see what is conductance. See, the conductance is equal to reciprocal of resistance. Reciprocal means 1 by R. See, ohm can be written as MHO. OHM is the resistance. MHO is the unit for conductance. Then we have to see what is resistivity. Remember that resistance and resistivity are not same. Resistance of a conductor is directly proportional to the length and inversely proportional to the cross-sectional area. R is directly proportional to L and inversely proportional to A. So to remove the proportional sign, we have to introduce a proportionality constant called rho. This is the resistivity. If L is equal to 1 meter and area is equal to 1 meter square, then rho will become R. Electrical resistivity of a conductor. We have to define what is electrical resistivity. This is at 3 mark. The resistivity of a conductor is defined as the resistance offered to the current flow by a conductor of unit length. Unit length means 1 meter and unit area means 1 meter squared of cross-sectional area. Electrical resistivity of a conductor is defined as the resistance offered to the current flow by a conductor of unit length 1 meter and the unit area of cross section 1 meter squared. The unit is ohm m. It is a constant for a particular material. It is constant. The reciprocal of the electrical resistivity is called electrical conductivity. Its unit is mho meter inverse. So we have to know what are all the resistivity for various types of material. For conductors, the resistivity is between 10 power minus 6 to 10 power minus 8. For glass and wood, it is found to be 10 power 8 to 10 power 14. Semiconductor 10 power minus 2 to 10 power 4. See, the conductors have lowest resistivity and the insulators have highest resistivity. Then see, we have to see what is the superconductivity. Or superconductivity means the resistance will be 0. Superconductivity means there will be no resistance. no resistance to current flow. This condition is called superconductivity. The ability of certain metals and their compounds to conduct electricity with zero resistance at very low temperature. Only when the temperature is very low, the substances enter into a state called superconductivity. The phenomena was first observed by Onnes in 1911. He found that Hg means mercury suddenly shows zero resistance at 4.2 Kelvin. At what temperature? 4.2 Kelvin. You may be confused with the option A 4.2 Kelvin, B 4.2 degree Celsius, C 4.2 degree Fahrenheit. You have to tick the answer 4.2 Kelvin. Theoretical explanation: Bardeen, Cooper and Schiff. This is called BCS theory. They theoretically explained what is superconductivity. Then we have to see what is transition temperature. The temperature at which the electrical resistivity of the material suddenly drops to zero and the material changes from normal conductor to superconductor. குறிப்பிட்ட டெம்பரேச்சர்ல நார்மல் கண்டக்டர் என்னவா மாறும்னா சூப்பர் கண்டக்டரா மாறும். அப்போ அதோட ரெசிஸ்டன்ஸ் வந்து ஜீரோவாக மாற்றப்படும். அது எந்த டெம்பரேச்சர்ல ஒரு நார்மல் கண்டக்டர் சூப்பர் கண்டக்டரா மாறுதோ அந்த டெம்பரேச்சர் தான் டிரான்சிஷன் டெம்பரேச்சர். அந்த டிரான்சிஷன் டெம்பரேச்சருக்கு இன்னொரு பேர் கிரிட்டிக்கல் டெம்பரேச்சர். டிரான்சிஷன் டெம்பரேச்சர்ல என்னென்ன சேஞ்சஸ் நடக்கும்? இந்த டிரான்சிஷன் டெம்பரேச்சர்ல எலக்ட்ரிக்கல் ரெசிஸ்டிவிட்டி டிராப்ஸ் டு ஜீரோ, எலக்ட்ரிக்கல் கண்டக்டிவிட்டி இன்ஃபினிட்டியா மாறும். ஏன்னா ரெசிஸ்டிவிட்டி ஜீரோ, conductivity is equal to 1 by resistivity. So 1 by 0. 1 by 0 வந்து infinity. Magnetic flux lines are excluded from the material. Excluded means வெளியேற்றது. Then carbon resistors. The application of superconductors will be dealt in a separate video. Application of all the concepts and all the things in the physics will be separately dealt in a separate video. Carbon resistors. Carbon resistors consist of a ceramic core in which crystalline carbon is deposited. They are resistors. They are cheap, stable and small in size. You can see the carbon resistors in various electronic gadgets and various electronic chips. We have to know that what are all the tolerable range of resistance. For silver it is 10%, gold is 5%, for red it is 2% and brown 1%. You have to remember this. Then we have to see what is BB, or for black 0, number, brown 1, red 2, orange 3, yellow 4, green 5, blue 6, violet 7, these values. These are all the powers which have to be mentioned in the 10 power 9s. I will tell you how to calculate the carbon resistance of the carbon resistors. You have to just memorize these numbers. How to memorize? We have to know the mnemonic. 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 Mnemonic means it's the shortest way. It is a simple way to understand, to memorize various complicated concepts. You have to see B.B. Roy, Great Britain, very good. Wisdom. B.B. Roy, Great Britain, very good wisdom. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. See B.B. Roy, Great Britain, very good wisdom. Then you have to see what is the combination of resistors. There are two connections. One is the series connection and one is the parallel connection. In series connection, what will be constant? I will be constant. V varies. In parallel connection, V is constant. I varies. We have to take what is varies, what is the variable. Let us consider the resistors R1, R2, R3, R4 connected in series. These are the R1, R2, R3, R4. This is the V1, V2, V3, V4 across the voltage potential difference between the ends. The potential difference across each resistor be a V1, V2. Then total voltage is equal to V is equal to V1 plus V2 plus V3 plus V4. Through Ohm's law, we know that V is equal to IR. So V is equal to IRS. R is the resistance in series. V1 is equal to IR1, V2 is equal to IR2, V3 IR3, V4 IR4. So V is equal to V1, V2, V3, V4, IR1, IR2, IR3, IR4. V is equal to I into R1, R2, R3, R4. From the equation 1 and 2, we know that IR is equal to I R1, R2, R3, R4. We have to cancel this I and this I. So RS is equal to R1 plus R2 plus R3 plus R4. In series connection, equivalent resistance of the number of series is equal to the sum of the resistance of the individual resistors. In capacitance, this will vary. 1 by Cs is equal to 1 by C1 plus 1 by, you have to compare these two and study. இது ரெண்டும் வேரி ஆகும். ரெசிஸ்டன்ஸ் வந்து சீரீஸில் இருக்கிறப்ப டைரக்ட் ஆட் பண்ணிடலாம். பட் கெப்பாசிட்டர் சீரீஸில் இருக்கிறப்ப ரெசிப்ராக்கல் எடுத்து ஆட் பண்ணணும். ரெசிஸ்டர்ஸ் இன் parallel. Consider 4 resistors of resistance R1, R2, R3, R4 connected in parallel. In parallel connection, the total in the parallel connection, the potential difference is same, but current varies. I is equal to V1, I1, I2, I3, I4. Be the current flowing through R1, R2, R3, R4. I is equal to I1, I2, I3, I4. Ohm's law, V is equal to IR. I is equal to V by R. RP is the resistance in parallel. For I1 V by R1, I2 V by R2, I3 V by R3, V by R4, I4. I is equal to I1 plus I2 plus I3 plus I4 equal to V by R1 V by R2 plus V by R3 plus V by R4. I is equal to, taking V as common, 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. So by equating the equations 1 and 2, we get V by RP is equal to V into 1 by R1, R2, R3, R4. We have to cancel V and V. This will become 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. This is the final equation. For capacitors, CR is C in parallel is equal to C1 plus C2 plus C3. கெப்பாசிட்டர்ஸ்க்கும் ரெசிஸ்டன்ஸ்க்கும் அப்படியே கான்செப்ட் வேரி ஆகும். நீங்கள் கான்செப்ட்ஸை கொஞ்சம் மெமரைஸ் பண்ணி தான் ஆகணும். டெம்பரேச்சர் டிபெண்டன்ஸ் ஆஃப் த ரெசிஸ்டன்ஸ். Resistivity of the substance varies with temperature. Temperature மாறுபடும் போது resistivity மாறுபடும். For conductors, resistance increases with increasing temperature. Temperature கூட கூட resistance increase ஆகும். Conductorsல 0 டிகிரியில் resistance R0, T degree Celsiusல RT அப்படின்னா RT is equal to R0 into 1 plus alpha T. is a very very important formula, very much useful in solving various problems. Alpha is the temperature coefficient of resistance. Alpha is equal to RT minus R0 divided by R0T. Temperature coefficient of resistance. The ratio of increase in resistance per degree increase in temperature is called alpha is equal to RT minus R0 divided by R0T. See, alpha is equal to RT minus R0 divided by R0T. The ratio of the increase in resistance per degree rise in temperature to its resistance at 0 degree Celsius. Metals have positive temperature of coefficient, temperature coefficient. That is, temperature கூட கூட resistance increase ஆகும். But non-metals, insulators, semiconductors, negative temperature coefficients, very very 1 mark, important 1 mark. So resistance decreases with increasing temperature. Temperature கூட கூட non-conductors, insulators, semiconductors resistance குறையும் temperature கூட கூட. Thermistor. You have to see what is thermistor. Material with negative temperature coefficient is called thermistor. They are non-metals and some alloys internal resistance of the cell. ஒவ்வொரு செல்லுக்கும் உள்ள ஒரு resistance இருக்கும். That is called internal resistance of the cell. The resistance offered to the current flow by the electrolyte of the cell is called internal resistance of the cell. ஒவ்வொரு செல்லுக்குள்ளேயும் electrolytes இருக்கும். அந்த electrolytes கரண்ட்டுக்கு ஆஃபர் பண்ணக்கூடிய ரெசிஸ்டன்ஸ்க்கு தான் internal resistance of the cell னு பேர். So determination of internal resistance. EMF of the cell is E. The resistance to the external circuit is R. Potential drop across R is equal to V equal to R. This is calculated from Ohm's law. The internal resistance of the cell is the small r. So V is equal to E minus IR. So IR is equal to E minus V. This will come here. So by dividing the equation 2 and 1, we get IR divided by IR. This small r, this capital R. I get cancelled. So E minus V divided by V. So the resistance of the cell is E minus V divided by V into R. This is the EMF of the cell. This is the potential drop across the resistor. This is the internal resistance. So EVR, if we know E, V and R, we can calculate the internal resistance of the cell. This is a very important formula. Remember this formula. This is very useful in solving various problems. It's also important in solving various problems in entrance examinations like KVPY, AAPMT. Kirchhoff's law. And we have to see what is Kirchhoff's law. Kirchhoff's first law and second law. First law is called current law and second law is called voltage law. There are two laws. Kirchhoff's current law states that algebraic sum of the currents meeting at any junction is 0. Algebraic sum of the current meeting at any junction is 0. Current towards the junction. Consider this as a junction. Current moving towards the junction. We have to take this as positive. Current, if we take this as another current moving away from the junction. Current junction நோக்கி வர கரண்ட்டை நம்ம பாசிட்டிவ்னு எடுத்துக்கணும். ஜங்ஷனை விட்டு விலகி போற கரண்ட்டை நம்ம நெகட்டிவ்னு எடுத்துக்கணும். For this is a simple illustration for you. 1, 2, 3, 4 be the conductors and I1, I2, I3, I4, I5 be the current. By Kirchhoff's law, see, I1 is coming towards, I2 is going away, I3 going away, I4 towards the junction, I5 towards the junction. These are all towards the junction. So towards the junction will be taken as positive. ஜங்ஷனை நோக்கி வர்ற கரண்ட்டுகளை நம்ம பாசிட்டிவாக எடுத்துக்கணும். அதாவது I1, I4, I5. ஜங்ஷனை விட்டு வெளில போகிற கரண்ட்டை மைனஸ் நெகட்டிவ்ல எடுத்துக்கணும். ஸோ இது எல்லாத்தையும் நீங்கள் ஆட் பண்ணிங்கன்னா ஃபைனலாக ஆன்சர் வந்து 0வாக இருக்கும். திஸ் இஸ் கால்டு கிர்ச்சாஃப்ஸ் லா. I1 plus I4 plus I5 is equal to I2 plus I3. See the previous equation. This is the previous equation. So this minus and minus go there. So sum of the currents entering the junction is equal to the sum of the current leaving the junction. ஜங்ஷனை நோக்கி வரக்கூடிய கரண்ட் எவ்வளவோ அதே தான் ஜங்ஷனை விட்டு வெளிலையும் போகும். This is the consequence of conservation of charge. So 1 mark, it can be asked in a twisted 1 mark. Then we have to see what is Kirchhoff's second law. Second law is also called voltage law. First law is called current law. Kirchhoff's voltage law states that the algebraic sum of the product of resistance and current. What is the product of resistance and current? Product of current and resistance is equal to voltage. Hence it is called voltage law. In each part of the closed circuit is equal to the algebraic sum of the EMFs in the circuit. EMF means electromotive force, that is the batteries. In cells. In this law is a consequence of the conservation of energy. First one is the conservation of charge. Second is the conservation of energy. Conservation of charge in the first chapter states that charges can neither be created nor be destroyed. Similar to the conservation of energy. Energy can neither be created nor be destroyed. Current in clockwise direction. This is the clockwise direction. Clock in a direction, so the clockwise direction, we have to take it as positive. Current in anti-clockwise direction is taken as negative. Okay. The further concepts in the second chapter will be dealt in the physics video 2.2. Please watch this video before coming to the physics video 2.2. I am doing this for the betterment of the government schools brothers and sisters. Government school படிக்கிற சகோதர சகோதரிகளின் நலத்திற்காகவும் அவங்க மெடிக்கல் கனவு அவங்கள வந்து நிறைவேறணுன்றதுக்காகவும் இந்த வீடியோஸ் நான் கிரியேட் பண்ணி நான் போடுறேன். If you like the videos, you can comment in the YouTube. You can like it in the YouTube. உங்களுக்கு எதுவும் டவுட்ஸ் இருந்துச்சுனாலோ queries இருந்துச்சுனாலோ நீங்கள் கமெண்ட் பாக்ஸில் கீழே டைப் பண்ணலாம், அல்லது என்னோட ஜிமெயிலுக்கு மெயில் பண்ணலாம், அல்லது என்னோட ஃபோன் நம்பருக்கு நீங்கள் கால் பண்ணலாம். I will try to clarify your doubts within 2 days. That will be a personal guarantee. You can also send your suggestions for making me to present a better videos. If you like the videos, please share the information about the videos with your friends who cannot afford tuition and coachings. Hope you understand the concept. If not so, mail me or call me. I will be very happy to clarify your doubts. Thank you for watching the video class. All the best for realizing your dreams. And this is Fee Free Brainery. Be free to assess. It's a venture by a student for the students. Thank you all. We will meet in the next video.